Welcome to The Explainer. Today, we're unlocking a hidden mechanical world that is absolutely vital for the future of transportation. We're looking at U.S. Patent 1263684B1, filed by Tesla. Now, on the surface, it might just sound like a patent for a lens cleaning system, but as we pull apart the schematics today, you're going to see an incredible piece of microengineering designed to solve a massive, real-world problem in autonomous driving.
Picture this for a second. Imagine you're in a fully autonomous vehicle, cruising down the highway at 70 miles per hour. Suddenly, a massive truck passes by and kicks up a huge splash of thick, opaque mud right onto the car's primary camera. Splat! What happens when a self-driving car literally gets mud in its eye? Unlike you or me, who can just turn on the windshield wipers or pull over to the shoulder, an autonomous system that loses its vision is instantly in extreme danger. It's a terrifying thought, right?
Okay, let's jump right into Section 1, the dirty camera problem, when autonomous vision goes blind.
You know, we spend so much time hyping up the artificial intelligence of self-driving cars, but we honestly kind of forget how vulnerable sensors are to everyday things like rain, snow, or mud. To really grasp what's at stake here, let's look at ADAS, or Advanced Driver Assistance Systems. This is that whole network of sophisticated sensors and cameras that actually let the car drive itself. The absolute crucial takeaway here is that they rely entirely on clear optical surfaces. If the camera lens feeding data to the AI gets blocked, the whole system is completely useless.
Just look at what we're dealing with out in the real world. This right here is actual baked-on debris caked onto a vehicle's camera. It completely blocks out the center of the visual field. It literally looks like a blinded eye, doesn't it? If this camera is supposed to be out there looking for pedestrians or reading lane markers, it is failing. The car is effectively driving blind.
Which brings us to Section 2, ditching the dome glass, why old solutions fail. So, the old ways of fixing this, they're just not going to cut it anymore for these next-gen vehicles. Historically, car makers would just use a protective dome glass, essentially hiding the camera behind a transparent shield. But honestly, that adds a bunch of bulk to the car. And even worse, it can cause significant optical distortion. It's kind of like looking through a fishbowl. This new patent proposes a direct lens wiper instead. It literally puts the cleaning mechanism right on the lens itself, keeping the image crystal clear while keeping the whole design incredibly compact.
All right, Section 3. Inside the cleaning system, a mechanical teardown.
This is where things get super cool. Let's do a little digital unboxing and really tear down this technology, starting with just how elegant the outside is. Right in the center, you've got the camera lens itself, but check out the structure wrapped around it. Up top, there's a tiny fluid nozzle acting almost like a mechanical tear duct, and resting perfectly flush against the lens, dual wipers, just sitting there like eyelids, waiting to sweep across the surface.
Now, if we magically strip away that outer shell to see what's hidden inside the cutaway, wow. You immediately see this crazy complex plumbing. You can see the fluid tube snaking its way in from a reservoir, and you can see just how deeply the lens assembly actually sits inside the housing, purely to make room for the tiny mechanical arms that drive those wipers.
Let's zoom in even closer on the cross-section here. See that large box-like section? That's the reservoir area, but it hooks up to an incredibly powerful drive mechanism hidden inside. To actually force those wipers through heavy wind resistance and sticky grime, this tiny little system packs a motor that spins at 12,000 revolutions per minute. That is wild.
12,000 RPM. And all that intense power boils down to one incredibly precise number from the patent, 0.355. That is the exact fraction of a second it takes for the wiper blade to do a complete full rotation across the lens, 0.355 seconds. That is literally the blink of an eye. The physical wiper actually blocks the camera for such a microscopic split second that the car's AI brain barely even registers a dropped frame.
But hey, speed isn't the only thing that matters, right? You need precision, otherwise you're just going to scratch up the camera you're trying to clean. The wiper blade itself isn't your standard cheap rubber. It is an absolute marvel made of flexible TPU, that's thermoplastic polyurethane. It hits that perfect sweet spot, tough enough to scrape away harsh road salt and chemicals, but soft enough that it absolutely won't scratch the delicate glass underneath.
Moving on to Section 4, detect, spray, and wipe. The brains behind the hardware.
Because let's face it, hardware is only half the story. A self-driving car can't exactly wait for a human to hit the wash button on the dashboard. It has to know on its own when it's dirty. So it essentially acts as a digital brain. The car is constantly watching its own video feed. It isn't just passively recording, it's actively analyzing image sharpness, checking the contrast, and monitoring color accuracy.
If suddenly a patch of the image goes blurry or the colors look washed out, boom, the system instantly knows it's got a dirty eye. And once that digital brain spots a problem, it triggers this hyperlogical three-step process. Step 1. The brain confirms, based on that quality drop, that yep, debris is definitely stuck to the lens. Step 2. It fires a signal to dispense liquid right out of that tiny nozzle. And Step 3. It kicks that 12,000 RPM motor into gear, sweeping the blade across the lens to clear both the fluid and the grime. All of that, start to finish, in a fraction of a second.
Now here's what absolutely blew my mind about this patent. We aren't just talking about spraying standard blue windshield wiper fluid here. Oh no. This thing has a whole versatile fluid arsenal at its disposal. Depending on what environment the car is in, it can trigger multiple reservoirs. It can spray specific solvents to melt away tough dirt, standard wash fluid, lubricants, or even alcohol-based solutions. But get this, the craziest fluid it can deploy? Oil.
I actually want to read this quote directly from the patent because it really highlights the preventative genius of this system. It says, "The oil can create a thin, uniform protective layer on the lens surface, reducing the adherence of future debris and contaminants." Think about that. It's not just cleaning the lens, it's actively treating it so the next time mud splashes up, it slides right off. It's essentially Teflon coating the car's camera completely on the fly.
All right, final part, Section 5, the future of clear vision, protecting the car's eyes.
Because if cars are really going to drive themselves everywhere, they need next-level protection. Like, what happens when the thread isn't a splash of mud, but a piece of gravel flying right at the camera? This brings us to what is easily the most sci-fi part of this whole patent. In high-risk environments, say you're blasting down a rough gravel road, the system actually uses its sensor data to anticipate damage. If it detects a rock flying at it, the housing literally snaps shut to block it. The car actually flinches, it blinks its eyes shut to protect its vision. How cool is that?
It is just an unbelievable piece of engineering. You've got a 12,000 RPM motor, an arsenal of different fluids, AI blur detection, and a literal physical flinch reflex, all crammed into a space roughly the size of a golf ball. And honestly, it leaves us with a pretty massive, thought-provoking question. If it takes this much complex, patented microengineering just to keep one single camera lens clean, how many other tiny, invisible mechanical problems have to be solved before cars truly drive themselves everywhere? It's like a giant puzzle, and it shows you just how monumental the road to a fully autonomous future really is. Anyway, thanks for joining me on this explainer. I really hope you found this hidden mechanical world as fascinating as I did.